So the Pythagorean theorem, you may have heard about it in your other classes. It's a very easy formula to use for solving for a missing length in a right triangle, and it's pretty easy to remember. If you have a triangle where the legs of the triangle, and legs are the sides that are attached to the right angle, so we call these legs. One of them can be called A and one could be called B, and then the slanted part, that's the longest side, we call that C. And the relationship between A, B, and C is A squared plus B squared equals C squared. So the nice thing about that, you got to see a picture of me there in elementary school. The nice thing about that is that if we know 2 out of 3 sides, we can solve for the third one by using square root. So if we look down here at this example, we're given a triangle, and it's a little confusing here because it looks like we've been given 9, 9, and 13, but actually this is the letter G. So it's not a really great letter. They should have used a different letter here, but um, so we're looking for this missing side G. So if we set that up into our formula, we know that A squared plus B squared equals C squared. So G squared plus 9 squared equals 13 squared. So 13 is the longest side. And the way you tell it's the longest side is you basically look at this angle, and if it points, see the little corner here? That points at the longest side. The legs are always attached. So these are both legs, and this is the longest side. Even obviously it's the biggest number, but we don't always know it's the longest side unless it's opposite the right angle. So if we solve this here, we have G squared plus 81 equals 169 because 9 times 9 is 81 and 13 times 13 is 169. And if we take G squared is equal to 88, G is going to be the square root of 88. Now you can simplify by using radicals like you learned in algebra by pulling out the square root of 4, and that's called 2. 2 times the square root of 22. But realistically, we want to know what is the square root of 88 as the decimal. So if we convert that to a decimal, I'm going to go to our calculator. So go to our calculator here. And we're going to use second square root, and we're going to put in 88 and enter. And we get 9 and this crazy fraction. So basically, we're going to say 9 and 3/8. So let's just divide 3 divided by 8 to give ourselves a decimal. I'm not sure why my calculator is not giving me decimals. I must have something off on the format, but that's okay. 9 and 3/8. So we'll go back to this. And 3/8 is almost 4/8. Waiting for my OneNote to come back. Here we go. So the square root of 88 is going to be 9, and I'm going to say it's probably around 9.4. So a little bit bigger. So if you remember in a previous lesson, we could ask the question, well, what's the bigger angles then? So if we look at this triangle, this side here is 9.4. So the smallest angle is going to be opposite this one. So this will be the smallest. And then the next smallest angle will be this one because that's opposite this side. And then the biggest angle, of course, is 90 because it's opposite the 13. All right, so let's move on to our next example. So we have a lot of triangles here. And the only question is when we're doing Pythagorean theorem is where we plug in the numbers. So if you look at the first 2 triangles, you'll notice that they both are giving you sides that are right along the right angle. So these are legs. See how these 2 sevens are both attached to the, kind of like home plate when you're playing baseball. So both of these, we're going to add them together. And a nice little trick is you can always put a plus here at the corner. Okay, so we could say that 4 squared plus 8 squared equals the missing side. So let's just call that x equals x squared. And we can move on and solve this. So this is going to be 16 plus 64 equals x squared. And if we add 16 plus 64, we get 80. And so x is going to be the square root of 80. And 80 is really close to 81, so I'm going to estimate that this is probably 8.95, right? I can use my calculator, but it's pretty close to 8.95. For the second one, again, these are both attached, and so this side's going to be x. So it's going to be 7 squared plus 7 squared equals x squared. And again, if I add these together, I get 49 plus 49 is x squared. And 49 and 49 are almost 100, so that's 98. And if I take the square root of 98, my answer is going to be really close to 10, because the square root of 100 is 10. So I'm just going to say that this is probably 9.95. And you can use a calculator. If you don't believe me, let's go to our calculator. Second square root, and I have a feeling it's going to give me a fraction, but it's 9.899, so 9.99. So I was even probably a little bit, I should have maybe had 9.99, not 0.95. So when in doubt, always go to your calculator, but in this case, 9.95 would be okay. It's a good estimate. Since I looked on the calculator, I'm going to go back and put the 99. Now the third one is an example where we're actually not looking for the hypotenuse. We've been given the hypotenuse. So if you notice, if I put the plus here, I don't have the other side here. So if I said 6 squared, and I'm missing this side, so I'm going to say plus x squared, and then you can always figure out, put the equal sign on the corner. So equals 10 squared. So I'm going to say 6 squared plus x squared equals 10 squared. And so this is like the example we did up above. X squared is going to be equal to 100 minus 36, because when I square those out, I get 100 for 10 times 10 and 36 for 6 times 6. And if I subtract 36 from 100, I'm going to get, anybody? This one's easy. 64. And if I take the square root of 64, I don't even get a decimal this time. I get 8. All right. So those are really the only two examples you have for Pythagorean theorem. You're either going to be adding the squares, as we did in example 6 and 7, or you're going to be subtracting one square from the hypotenuse in order to get the missing side, right? And you can tell because if you're given the longest side, you're going to end up subtracting, like in example 8. And if you're not given the longest side, you're just going to be adding the squares, just like we did in example 6 and 7.